Hi, this is Susmitha, Assistant Professor, Department of Computer Science and Technology. Today we are going to discuss about the Address Resolution Protocol. Address Resolution Protocol is the most important protocol of the data link layer. It is a network layer protocol used to convert a IP address, that is the network or logical address, into a MAC address, that is the hardware or physical address. The computer programs or application use logical address, that is the IP address, to send or receive messages. However, the actual communication happen over the physical address, that is the MAC address. To send a datagram over a network, we need both the logical and physical address. IP addresses made up of 32-bit, whereas MAC addresses are made up of 48 bits. So ARP enables each host to build a table of IP address and corresponding physical address. So that ARP relies on broadcast support from physical networks. The address resolution protocol is a request and a response protocol. The two types of ARP messages are ARP request and ARP reply. ARP operation. ARP operation, it is maintain a cache table in which MAC addresses are mapped to IP address. If a host want to send an IP datagram to a host, the first check for a mapping in the cache table. If no mapping is found, it need to invoke the address resolution protocol over the network. It does this broadcasting an ARP query onto the network. The query contains the target IP address. Each host receives the query and check to see if it is match its IP address. If does match, the host send a response message that contain a link layer address back to the originator of the query. The originator add the information contained in this response to its ARP table. For example, to determine system B physical address, system A broadcast address, that is ARP request containing B if IP address to all machine on its network. So the IP address request and reply. All node except the destination discard the packet but update their ARP table. So the destination host construct ARP response packet. ARP is a response is unicast and sent back to the source host. The source store target logical and physical address pair in its ARP table from ARP response. If target node does not exist on same network, the ARP request is to send to default router. So the ARP packet block diagram. So the hardware and prototype. Hardware is nothing but the hardware length and protocol length, and here the request and reply. So the source address, hardware address and protocol address, the destination hardware address, destination protocol address. So the reverse address resolution protocol allows a host to convert its MAC address to the corresponding IP address. The data link control deal with procedure for communication between two adjacent nodes, that is node to node communication, no matter whether the link is dedicated or broadcast. So the data link control service include three things: the framing, control flow, and error control. So framing, the data link layer, that is bit of a frame message into frame. So the each frame is distinguished from other. So here the framing. So the node A adapted to the node B, the bits are transmitting it. Although the whole message could be packed in one frame, that is not normally done. One reason is that frame can be very large, making flow and error control very inefficient. When a message is carried one very large frame, even a single bit error would require the retransmission of the whole frame. When a message is divided into smaller frame, a single bit error affect only the small frame. The framing is the data link layer, separates a message from one source to a destination by adding a sender address to a destination address. The destination address defines the packet is to go. The sender address help to receive acknowledge the receipt. Framing size. Framing size is fixed or variable size. The fixed size is called the cells. And if in a fixed size framing, there is no need defining the boundaries of the frame. The size itself can be used as a delimiter. If a variable size framing, we need to define the end of one frame, the beginning of the next. The two approaches were used for this: a character oriented approach and bit oriented approach. Character oriented approach, that is in character data to be carried or 8-bit character in one frame from the next frame, that is 8-bit. One byte, that is flag, is added at the beginning, at the end. The flag composed of protocol depend on special character signals start or end the frame, the starting frame and ending frame, between the message. Byte stuffing or character stuffing. The byte stuffing is the adding of one extra byte whenever there is flag or escape sequence in the text. So the byte stuffing is added to the next data section of the frame when there is a character with the same pattern as the flag. The data section is stuffed with an extra byte. The byte is usually called the escape sequence, escape character, and is predefined bit pattern. Whenever receiver encounters the escape character, it removes it from the data section and treats the next character as data, not as delimited flag. Bit oriented framing. In a bit oriented framing is a sequence of bit to be interpreted by the upper layer as the text, graphic, video and audio. In addition, the header and trailer, we still need a delimiter to separate one frame from the other. Most protocols use 8-bit pattern, so the delimiter to define the beginning and end of the frame. So the 8-bit pattern is the zeros and ones is determined. If the flag pattern appear in the data, the receiver must be informed that this not the end of the frame. This is done by stuffing one single bit to prevent the pattern from looking a flag. This is called a bit stuffing. So the bit stuffing is the process of adding one extra whenever 5 sequence of 1 is followed by the 0 in the data. The receiver does not mistake the pattern, so for a flag in a bit stuffing, if a 0 5 sequence 1, so 0 initially the 0 value, that is flag value, and the 5 followed by a 5 ones followed by a 0, so an extra 0 is added. This extra stuffed bit is eventually removed from the data by the receiver. The extra bit is added after 1 followed by 5 regardless of value of the next bit. This guarantees that the flag field sequence does not inadvertently appear in the frame. Bit stuffing. So the data from upper layer stuffed the data, 2 extra bit are added, unstuffed data to the upper layer. Flow control is referred to the set of procedure used to restrict the amount of data the sender can send before waiting for their acknowledgement. The receiving device has limited speed and limited memory to store the data. So the receiving device must be able to inform the sending device to stop the transmission temporarily before limits are received. If we require a buffer, a block of memory for storing information until they are processed. The flow control, so the data link layer producer sending node and producer, that is the receiving node, frames are pushed to the flow of control. Flow control method is developed to control the flow of data, stop and wait and sliding window. Stop and wait is it is the scheme of the stop and wait algorithm, simplest scheme. So the stop and wait method, the sender wait for an acknowledgement after every frame it sends. When the acknowledgement is received, then only next frame is sent. The process of alternatively sending and waiting for a frame continues until the sender transmits the end of the transmission frame. The flow control, each time the acknowledgement is received. If the acknowledgement is not received with the allotted time, then the sender assumes the frame is lost during the transmission, so it will retransmit the frame. So the acknowledgement may not arrive because of the following 3 reasons. Acknowledgement frame is original frame is lost, acknowledgement is lost, and acknowledgement arrive after the timeout. So the 3 reasons the frames are lost. So advantages of stop and wait. So it's simple as each frame is checked and acknowledged before the next frame is sent. Thank you.